Bonsuelo, mathletes. Okay, today we're going to deal with trig functions on the calculator. First thing I want to mention is that there are different settings on the calculator, okay, that if you don't have it in the proper setting, you're not going to get the proper answer, okay? We're using degrees. There are other things called radians and gradients, okay? Your calculator has to be set on degrees. For a graphing calculator, you push your mode button and make sure it's set in degrees. On a cheesy scientific calculator, you probably have a little button that says DRG someplace. Keep pushing it until it says DEG, okay, for degrees. Okay, second thing, and this is very important, not that the other thing isn't, but inverse and reciprocal are not the same things. Okay. When you find a trig function, remember you take the trig function of an angle and you get a number. That's just a trig function. Take the sine of 30 degrees, you get a half, or on your calculator it'd be 0.5. Okay, but if you're doing the opposite of that, in other words, if I give you the number and you're trying to find the angle, that's doing the opposite, that's inverse. Okay? That's not the same as reciprocal. Reciprocal are cosec, that means flip something over, okay? Cosecant, secant, and cotangent are reciprocals. But on your calculator, you don't have those, okay? So we're going to have to do something. But what you do have on your calculator is sine to the -1, cosine to the -1, and tangent of -1. Those are inverses. And that's what you do when I give you the number and you're trying to find an angle. Okay, so for instance, here, let's deal with reciprocal problems first. Okay, cosecant of 17 is the reciprocal of sine of 17. So I write the reciprocal of the sine of 17, 1 over the sine of 17. And then you have to punch that into your calculator, exactly what it says, 1 divided by the sine of 17 degrees. And then you push enter and you should get that number to 4 decimal places. Okay, so cosecant is the reciprocal of sine. All right, it's a reciprocal of a trig function. You don't take the reciprocal of the angle, you take the reciprocal of the trig function. Okay, now let's take a look at the second case where you're trying to find an angle. Okay, you have sine of theta equals 0.4848. That's an inverse problem. We're going backwards. Okay, so what you're going to use is the inverse sine to the -1. Remember, that's a function. Sine to the -1. Remember, a negative exponent means reciprocal, except when you're dealing with function notation, and they are called trig functions. Sine to the -1 is not 1 over sine. It means inverse sine. It means do the opposite. So if you take the inverse sine of 0.4848, you get, and we just round it off to the nearest degree, you get 29 degrees. Okay, let's first of all go through just finding trig functions. Okay, and we'll round these off to the nearest hundredth, okay? So we'll take it out to 2 decimal places. Okay, in the first case, and again, make sure your calculator's set on degrees. You type in the cosine of 67. I mean, that's really all there is to it. And you get 0.39, okay? Now, the key to the reciprocal problems is rewriting them. So if you don't rewrite it, you're probably going to do it incorrectly. This is the same as 1 over the cosine of 67 degrees. And then you type in exactly what it says, 1 divided by the cosine of 67 degrees. And then, you push enter. And when you do that, you get 2.56. Rounded to the nearest hundredth. Okay, I just realized I didn't put I didn't put an angle on number 3. Oh, we'll do the cosine of, let's take 12 degrees. Okay? All right, so this would be 1 over the tangent of 12 degrees. Okay, so we're going to just type it in exactly. Like I say, if you type it in, if you write it, you just type in exactly what you write. And so what you're going to end up with is 4.70 that's it, 4.70 to 2 decimal places. Okay? Now, let's do the opposite of this. Here, you're given the number, and we're looking to find the angle. So what we're going to type in, and you don't have to write this, but I kind of would recommend you do, is we're going to type in the sine to the -1 of 0.7146. Okay? So you have 0.7146, and you take the inverse sine of that. You probably have to push second function button, and we'll round to the nearest tenth. That's 45.6 degrees. Okay? We'd have the inverse cosine of 4/9. And you just kind of just type in exactly what it says. And you should get 63.6 degrees. And the inverse tangent of 7/3. So you just, again, I would write tangent to the -1 of 7/3. And you get 66.8 degrees. Okay? So there's just, sine and inverse sine. Sine, you're given the angle, you're trying to find the number. Inverse sine, you're given the number, you're trying to find the angle. It's really all it comes down to. Okay. Now, solving right triangles. What I'm going to ask you to do is, given a triangle, or maybe given you a word problem, where you have to, where you have a right triangle, is find the 3 missing pieces of information. Okay, this is what I suggest you do, and I can't emphasize doing it this way more. I can't emphasize it more. You'll really make fewer mistakes if you do this. Write the 3 equations first, then solve them. Okay? And what I suggest you do, let's take a look at number 1. You circle the given pieces of information. Okay, and then of course there's also the 90-degree angle. Okay, what do you think would be the easiest thing to find here? Well, angle A, hopefully. So we have angle B plus A equals 90 degrees. Because since one of the angles is 90, the other 2 are always going to be 90. Well, what's angle B? Angle B is 13. Okay? Don't solve it. Just leave it. That's one equation. Okay, so we've found angle A. Okay? Now, let's and really we don't have to circle the right angle because it's always going to be there. Why didn't I need to find a trig function? Because I wasn't mixing up sides and angles in one equation. But let's find side B here. So notice what I'm going to be using is the given angle, the given side, and side B. Well, relative to the given angle, B is opposite, 4, the other side, is adjacent. So since it's opposite over adjacent, I'm going to use tangent. So we have tangent of 13 degrees equals the opposite over the adjacent. Okay? That's the next angle. That's the next equation. Okay, now, we found B, or at least the equation for B. Now let's find side C. Again, we're going to be mixing up angles and sides. So, relative to the 13 degrees, C is the hypotenuse and 4 is the adjacent. So let's use the adjacent over hypotenuse. That's cosine. So we have cosine of 13 degrees equals 4, the adjacent, over the hypotenuse, which is C. Now, let's solve each of these. Okay, so we have A is going to be 90 minus 13. And you don't necessarily need to write this. If you just want to go 90 minus 13 and tell me what the answer is, that's fine. We get rid of the 4 in the denominator by multiplying, and we get 4 times the tangent of 13. Okay, fine. And on this one, what we're going to do is we're going to multiply by C, right? Get rid of the fraction. And so that's C times the cosine of 13 degrees equals 4. And then what happens? I divide by the cosine of 13. And now you just plug all that in your calculator. So we have 90 minus 13, obviously you don't need to do in your calculator. That's just going to be 77 degrees. Okay. Next one is 4 times the tangent of 13, which will give us, what would I want this to the nearest tenth? B is going to be 0.7. Okay, and then for C, we're going to take 4 and divide it by the cosine of 13. And so C is going to be 4.1. Write your equations first, then solve them. You'll make fewer mistakes. Okay, let's take a look at another example. Okay, here, well, I don't know any angles, so I know these two sides, and of course, then there's the 90 degrees. Well, what's the easiest thing to find? Probably side B, because 4 squared plus B squared equals 7 squared. Again, I didn't need a trig function because, it was all, I wasn't mixing up sides and angles. It's just sides. Okay, so fine, I've found side B. Let's find angle A now. Okay, now angle A, this side is the opposite. This side is the hypotenuse. Opposite of hypotenuse is sine. So we've got sine of A equals 4 over 7. Fine. Okay, so that'll find me A. And now what do I do to find B? Well, this side's the adjacent, and this is the hypotenuse. So that'd be cosine of B equals 4/7. Now, again, at this point, you can do the rest in your calculator, but you're going to have B squared equals 49 minus 16. So B squared is going to be what? 33. So B is going to be the square root of 33, and also the negative square root of 33, but again, since it's a side, we can throw that one out. Okay. For the sine of A, what are we going to use? We're going to use inverse sine. So A is going to be sine to the negative 1 of 4/7, because we're doing the opposite. We're finding the angle. And then we'll do that in the calculator in a second. And then B will be inverse cosine of 4/7. Okay, so let's take the inverse sine of 4/7, and we get 34.8. So A is 34.8 degrees. And then we'll take the inverse cosine of 4/7. And you get 55.2 degrees. Now I want to point something out. When you're done, your two angles should add up to 90 degrees. And, if you add these up, they do add up to 90 degrees, so we're good. Okay, let's just take a look at one. Notice what I've given you is different things here. On problem 1, I gave you one angle and one side. On problem 2, I gave you two sides. On problem 3, I've given you two sides, but they're different than the two sides that I gave you in number 2. On 2, I gave you one of the sides and the hypotenuse. On number 3, I haven't given you any hypotenuse. Okay, so what have I given you? I've given you the 4 and the 7. Okay, so let's write 3 equations. So we're going to have 4 squared plus 7 squared equals c squared. Okay, that's going to give us the Pythagorean theorem. Now let's find angle A. So relative to A, this is the opposite, and this is the hypotenuse. So we have tangent of A equals 7/4. Okay. So that'll give us A. Now to find B, this is the opposite now when this is the hypotenuse. So it's still tangent, but the opposite is 4 and the adjacent 7. Okay? By the way, just a word of advice. On all of these problems, solving the right triangles and the word problems and everything, you don't need to use secant, cosecant, and cotangent. You can get away with just sine and cosine and tangent. And that's kind of helpful to know. Anyway, so we get c squared equals 16 plus 49, which is going to be 65. So c equals the square root of 65 and negative square root of 65. And of course, we'll cross that out. And probably in Alex, they're going to make you find the square root of 65, but you can just leave it like that for me. Okay, for this one, A is going to be the inverse tangent of 7/4. And B is going to be the inverse tangent of 4/7. Okay. So for angle A, we're going to take the inverse tangent of 7/4, which is 60.3 degrees. And for B, we're going to take the inverse tangent of 4/7, which is 29.7 degrees. Oh, what happened there? And notice if you add up those two angles, you get 90 degrees. So at least we're in the ballpark of reality. Okay? So that's pretty much it. Again, sometimes in Alex, they're going to give you word problems, but it just comes down to solving a triangle is all it is, whether it's in a word problem or not. Hopefully that helps you. This is it. It's kind of sad. The last video. Consuelo, everybody.